So this week, we are going to briefly talk about descriptive data mining. And we won't go into too much details because if you are taking other courses, they probably will have more advanced procedure that other faculty will discuss. So we'll only briefly talk about what will be the basic data mining that you can do, especially in SPSS. Okay. So why do we need to utilize data mining? The reason is really simple, because right now we have too much data. So in the past, we know exactly what we want to collect, and we know exactly what type of analysis you want to do based on the data we have. But nowadays, because all the data are collected, it will be almost impossible for you to manually determine which variables will be more important for your analysis and which variable will be most relative to whatever outcome you want to predict. So data mining kind of can help us resolve that, because we don't really need to have any set of goal. We can just let the program run and to see if we will be able to obtain any insight from the outcome observed from the data mining result. Okay. So data mining basically is also what we call unsupervised learning, because we will be able to include high-dimensional data, meaning we will be able to include a lot of different variables in our analysis, right? So it's very different from the, say, linear regressions we learned in the past, because when we were doing linear regression, for example, in most situations, we only want to include maybe one independent variable, or maybe two or three at most. But in these situations, we don't want to have any assumptions. We simply want to assume everything is relevant to our analysis. So before we conduct any advanced analysis, we want to make sure that we will consider all the possibilities and do the predictions based on everything we have on hand. Okay, so we don't have any, there's no outcome variable to predict, and there's no measure of accuracy. So you cannot assume that the result you get from the data mining will be valid or not. And you can only use this as an initial exploratory stage for you to understand the data better. So one of the common analysis that we often run is the cluster analysis. So this is a typical example of cluster analysis. In the data set, we may have so many different variables, but in this particular example, we only have two. We have age and income, right? So let's say I have a data set like this, but I don't know exactly what type of analysis I want to perform. I actually don't know the relationship between these two. So one thing I could do is I run a cluster analysis, and maybe I ask the program to divide all the records into 3 or 4 different groups. In this case, I'm going to divide the data into 3 groups. So when you are trying to run a cluster analysis, basically we can use different algorithms depending on the distance between any 2 individuals. And we will be able to put them into the group based on the similarities. So in this case, we have 3 groups, one in purple, one in red, and one in blue. And this way, we will be able to tell, I know I kind of can divide people into different groups based on their age and income, right? So this is why we want to utilize the cluster analysis, because especially in marketing department, because this is a very good way for us to divide customer into different groups. For example, high spending group and low spending group, and things like that. And for the insurance company, I can also use that to say, okay, I have the high risk driver, low risk driver, or medium driver. So you can do anything you like, and based on the result you obtain from there. And another thing that we often use cluster analysis is that we can use this to reduce the number of variables that we are going to use in the long run. Imagine you have tens of thousands of different variables. And when you run a cluster analysis, essentially you may have a situation like this. I have age, I have income. So I draw the graph with age and income, and I realize that, wait a minute, there's actually a relationship between age and income, right? Because when I'm dividing the customer into different groups based on income, I have the low income, medium income, and high income. Essentially, it is somehow similar to dividing the customer based on their age. So younger people, mid-age, above 65. So this way, I can actually reduce the number of variables, meaning later when I'm doing the analysis, maybe I can choose either income or age. I don't have to include both. So this can speed up all the analysis performance in the long run. So this is only a variable example, but when you have tens of thousands, we will be able to reduce the number of variables significantly. So in today's class, we will only discuss two different cluster methods. One is what we call a hierarchical clustering, and the other one is a k-mean clustering. And so for the hierarchical clustering, basically, we always start from a group of 1 observations. So let's say I have a classroom of 40 students. Every single student will start their own group as an initial point. Then I can try to use different algorithms to compare the similarity between any two groups. For example, maybe I realize that, okay, 2 of you are pretty similar. I will put you guys together. And the other 2 students are very similar. I will start to put them together. So starting from a group of 1 individual student, starting with a situation where I have a group of 1, I can start to put students together into a group of 2, 3. So essentially, I can put the entire class into one group. So that's why we call it hierarchical clustering. I can try to reduce the number of groups from n to 1, right? Then I can kind of decide how many groups I want based on the result I get. So we will talk about that later. The k-mean clustering is a little bit different. We basically need to predetermine how many groups I want to have. So let's say I want to have 3 groups in the classroom. First, I will initial 3 points randomly. So maybe I will have a point here, the other point on the right-hand side of the classroom, the other one in the back of the classroom. Then I start to measure the distance between each of the students to that particular location. If you guys are closer to this one, I'm going to assign you to this. And I do this several times. After I assign the group student to that particular, to 3 different groups, I will remeasure the distance, then try to rearrange the clustering. And eventually, I will be able to assign students to the group that's similar to you best, all right? So let's go back to the hierarchical clustering a little bit. How can we measure the distance between any 2 observations? The calculation is actually pretty simple. We basically just need to figure out what would be the geographical distance between any 2. So if we have 2 variable situations, I simply use a distance of x squared plus distance of y, and sum of them together, divide and take the square root. That will be the actual distance. When you have n or n different variables, I still use the same formula. So this way, I will be able to measure the physical distance of 2 groups very easily. So this is what we call the Euclidean distance. But in the SPSS, you can also choose different calculations depending on what you need. Obviously, when you are using a different way to calculate the distance, the outcome will be slightly different. Okay. Now, one issue with this way is that imagine when you have multiple variables, and those variables are using different scale. I will use the age and the income, for example. We know the minimum age is 0, right? The maximum age is 100, so the range is only 100. But when we are talking about income, the minimum income can be as low as 20,000. The maximum income can be a couple millions, for example. So when you are trying to measure the distance, you can imagine the result will be mainly affected by the income rather than the age, because the two scales are very, very different. So one thing we can resolve that issue is to convert everything into standardized normal, right? Remember, last class we talked about how we can convert the variable into z-score. We can do that here as well. So we find out the z-score for age and we find out the z-score for the income. Then we try to calculate the distance based on their z-score. So this way we can ignore the effect caused by the scale differences. So that takes care of the scale variable measurement. But some of the variables are actually categorical variables. So one of most commonly used questions in the categorical data is a yes or no questions. So we know there are only two possibilities, either 0 or 1. So it won't be suitable for us to, measure the actual distance between two data points. So when we are doing that, we can try to calculate something called matching coefficients. The matching coefficient basically can tell you the similarity between two observations when we are dealing with a binary categorical data. So what's the formula? For the denominators, we want to find out how many variables you get a matching value for two different observations. And we use that divided by the total number of variables. We will be able to get the matching coefficients. So the value of matching coefficient will always be between 0 to 1. Let me show you this example here. On top of the table, this is our data. I have 3 observations, 1, 2, 3, with 3 different variables, V1, V2, and V3. So what I'm going to do is to create a matching coefficient table. And this way I will be able to compare the coefficients, matching coefficient between any two pairs. So these 3 will always be 1 because I'm comparing the first observations against first observations or the second against the second. And the reason that we get a 1 is because if I compare 1 to 1, I get 3 matching variables. So 3 divided by 3 will still be 1. How do I get 2/3 when I compare 1 and 2? So let's say if I want to compare 1 and 2, I get a match here. I don't get a match here. I get a match here. So how many matching variables I have? 2. How many variables I have? 3. So 2 divided by 3. That's how I get the answers, right? So I basically complete the table. I will be able to tell which 2 variables are close together based on the matching coefficients. Now, there will be some issue when you are trying to using matching coefficients. Some argument about matching coefficient is that we compare the result based on whether the answer is yes or no. And we say the 2 individuals are similar if the answer are yes. That's reasonable, but some people argue that it's not reasonable when the 2 people answer no, and they are still considered similar. So they feel that if the answer is yes, they are similar. But if the answer is no, it doesn't mean that they are similar as well. One typical example would be like this. People who, I may ask some questions about whether you own a boat or not. And if there are 2 individuals, both on the boat, I will say they are similar because they are rich, maybe. But if I ask 2 people, both do not own the boat, it doesn't mean that they are similar because the majority of people do not own the boat. Okay, so if your data meet those criteria, you can use something called J-CAR coefficients. So the J-CAR coefficient calculation is slightly different. For the denominators, I want to find out how many variables will have a matching non-zero for two different observations. And for the denominators, I want to find out how many total variables and use that subtract by the number of variables with matching 0. I know it's a little bit difficult to understand, but let's take a look at this example. This is the same example I showed you earlier. So I still have 1 over here. And let's see how I get half when I compare 2 and 3. When I compare 2 and 3, what do I get here? A matching 1. So I get a matching 1. I'll use a V to denote that. Here, I'll get a matching 0. So I will just call this, what do I call this? I shouldn't call this V. I should call this I'll just write write 1 to denote it's matching 1. This is matching 0. And here, I do not get a match. So the reason I get half here is for the denominators, I want to count how many matching 1s I have. So in this case, how many matching 1 I have? It's 1. For the denominators, I first need to calculate how many variables I have. I basically have 3. I want to use 3 subtract by the number of matching 0. In this case, I have 1 matching 0. So that's how I get half for that part. So when you are using J-CAR coefficients, basically, you will be able to avoid putting 0 into the same group. Now, when you are dealing with other type of ordinal categorical variable, you can simply use chi-square measure. So that's another thing you can do. So now let's get into the detail of hierarchical clustering. So as I mentioned earlier, when we are using hierarchical clustering, I will first put every individual into their own group. Then I will try to find a way to measure the similarity between any two groups. And then finally, when the distance is shorter, I will be able to put them together. All right? So basically, there are many different ways for me to calculate the distance between any two groups. We can use single linkage, we can use complete linkage, group average linkage, and we also have the median linkage, central linkage, and the one method. Just remember, when you are using SPSS, the first 3 are under a different name. So for the single linkage in the SPSS, it's called nearest neighbor. For the complete linkage, it's called the farthest, and the group average is called between group linkage. So let me tell you what that means for each cases. So for the single linkage, basically, I want to find the closest distance between the two groups based on the individual in each of those groups that are closer to each other. For example, everyone on the left-hand side of the cluster is group 1, and everyone on the second part of the cluster is group number 2. So and each of you will be 1 observations, right? I will figure out which 2 will be the close one together. So in this case, I figured that, okay, 2 of you are sitting right next to each other. So the closest distance between these two groups will be these 2 gentlemen over here. Okay, so that's why the single linkage is also called the shortest neighbor in SPSS. Is that what you call? Yeah, nearest neighbor, not shortest neighbor. The complete linkage is the opposite. I want to find the distance across the classroom. So for this group, maybe I will use you, and the other group, I will use the lady in the back over there. So the distance will be the similarity between these two groups. So that's why in SPSS, it's called the farthest neighbors. The group average linkage is slightly different. Basically, I want to measure every single pairs between two groups. Then I find out how many comparisons I'm going to make and find out the average among that. So that's why it's called that's why it's called group average linkage. And again, in SPSS, it's called between group linkage. So this way, I will be able to put people together. So every time when I'm doing a comparisons, I will combine the two groups that are closer to each other together. So essentially, I will have the group size of 40 students instead of a group size of 1. So basically, when you are working on that, you can draw a graph called the angiogram like this. What you can get from this type of graph is that initially, for example, I have how many data I have? I have 20 data. So I put 20 individual observations into their own group. Okay. And then those 2 or 3 are very close to each other. So when I move to the right-hand side, these 3 individuals will be put into the same group first. Then initially, I can move to the right, and you will see that every single individual will be under the same subtree. So that means I combine every single one into one group. So how can I determine how many, say, how many clusters I need to have? What I can do is I can draw the line anywhere you want. So if I draw the line here, I can tell that, okay, I have the first subtree here, second subtree here, third subtree here, and the last subtree there. Okay? So this way I know I will be able to put people into 4 groups. If you want to put people into more groups, I simply move the red line to the left-hand side. Then I will have more groups with less people in it. Then, okay? So moving this line, you will be able to determine how many clusters you want to have. One question people often ask is, how do I know how many groups will be a better options for me to choose from? In this case, I can have as many as 20 groups. I can have as small as 1 single group. How do I know 4 groups will be the best way to go? Are there any better answers or things like that? One thing you can do is I can try to move this line to the right-hand side a little bit more. What you are going to see is that, for example, maybe my first line is over here, right? This is my first line. And when I'm trying to combine people into different groups, the next line will be here. And this is the third line. Maybe, around here. Then here. And we're kind of going down on the right-hand side. So one good decision for you to make is that you kind of will realize that the distance will kind of getting smaller and smaller. And sometimes you will get the exceptions, but that's okay. But later on, the distance will be so small, but after that, the next one, you will be jumping back to a big gap. Okay, for example, in the previous one, I have a gap like this. Here, the gap becomes much larger. Okay? Whenever you get the large jump, what does that mean? It means that you are putting 2 groups that has more differences between them together. Okay? So practically speaking, it's not a good idea because what's the purpose of clustering analysis? The clustering analysis is that I want to put people or the observations that are similar together. Okay? So a good way for you to determine how many clusters that you want to have is once you figure out the smallest jump, if the next one goes pretty large, I will stop right there. So in this case, I actually want to stop at the red line. Red line would be a better solution here. So what do I get from the red line? I get one cluster. So this is the first cluster. This is the second cluster. This is the third cluster. Okay? So this way you kind of avoid putting people that are very different together. Does that make sense? Obviously, this is not the only way for you to do it, but this is a generally good decision for you to make. You can choose any clusters you want, but most likely when you are doing this type of procedures, you won't get the result won't be too bad. I can just say that, all right? So that concludes the hierarchical clustering. For the k-mean clustering, it is slightly different. I basically has already decided how many clusters I want to have. So I will find out any random 3 points, as I mentioned, that I may have so many data points like this, right? Then I will initially decide where would be my initial point. Then I put those people together based on the distance to that dot. Once I put those individuals into that particular locations, what you are going to do next is to recalculate the central. Okay, so these 3 dots will be erased. It will be recalculated based on the new observation. So these 4, maybe the dot become here, and these 3, the dot will become right here, and these 3, the dot will become right here. Then I will reassign those individuals to these 3 new dots, essentially. So when you do this process over and over again, you will be able to put people that are similar to each other together. So this is a comparison between the hierarchical clustering and the k-mean clustering. Most likely, we will use the hierarchical clustering when the data size is on the smaller side, for example, 500 observations. And when you have more observations, using hierarchical clustering may pose some issues, because if you have tens of thousands data, it means that initially you need to put every individual, every single observation into their own clusters, and the calculation can be slow, and it can take a long time for you to reach a reasonable cluster size. But the good thing about hierarchical clustering is that you will be able to see visually how observations are put together in the process. For the k-mean clustering, it usually will be more suitable when you have more data. But the downside is that you have to predetermine how many clusters you want to have, and also it doesn't allow you to choose the way the distance are calculated. So in terms of analytical result, whatever outcome it provided can be somehow limited. So that's another thing you need to consider. Another issue with k-mean clustering is that you cannot really handle any categorical data. For the hierarchical clustering, I know I have one way for me to calculate the distance for the scale data. I have a different way to calculate based for the categorical data, but the k-mean clustering will not be able to handle any categorical data. When you have categorical data, you'll be treated as the scale variables. Okay? So when you have a situation like that, you can use other methodologies, for example, the two-step clustering or things like that. All right. Now, for the hierarchical clustering, although I mentioned that we will be able to handle the scale variable, we can also handle the categorical data. But in SPSS, you cannot handle both type of variables at the same time. You can either assume everything will be scale or you assume everything will be categorical. But I believe that's just a limitation for the SPSS. If you are using other software or if you try to write your own code, maybe you will be able to handle both at the same time. But as I mentioned, the cluster analysis does not really help you to provide any useful outcome. It can just to help you understand your data better. So I wouldn't say that would be an issue for most of us. Okay. Now, let's talk about text mining. Another thing that we often do is text mining. And what's the difference between text mining and clustering analysis? One thing about text mining is that basically whatever information we collect is what we call unstructured data, because we don't really know how many observations we are going to have and how many variables we are going to have when we are trying to scan the text into the data set. So one thing we want to do a text mining is to convert the text information into something that can be analyzed by the software such as SPSS or other software. Okay, so in the SPSS we are using, we don't have the ability to do the text mining. You can do the text mining by purchasing additional text mining package from SPSS. But the one we are using, we don't have that ability to use. But we can still try to understand the process behind it. So basically, we will be able to read every single text file. And every single text file will be considered as one observation. And from that, each of the observations, we will try to identify all the vocabulary that we will use in that particular text file. And each variables will be used to represent one of those vocabulary that show up in those text files. Then there are two different ways for you to collect the data. The first type of table, we simply use 0 or 1 to denote whether that particular word show up in that document or not. If the word show up in that document, we will set a 1 to that particular variables. If the word does not show up in that document, we'll put a 0. And we call that present, absence, or binary term document matrix. The second type is what we call a frequency term document matrix. For that one, we will count how many times each of those words show up. So obviously, if you want to get if you prefer to get more insight from the data you have, the frequency term document metric will be the way to go. The binary one will provide you less information on that. So this is an example. We may have the customer's comment on the internet, and each comment will be considered as one observation. And we call this unstructured because sometimes it is longer, sometimes it is shorter, and each of those will use different words, all right? And so the first thing the software is going to do is to tokenize every single observations. So what it's going to do is that they are going to say, for example, the first one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 words. I'm going to create 13 variables. Each of these variables will be used to represent each of the words show up here. Then when I read the second comment, if some of the word has already been included, I can count it. If it's not included, I can create a new variable. So essentially, the variable size will be much, much bigger. Another thing that you need to consider is the word may show up in different format, different tense. And cut will be, you may have cuts, and things like that. You need to convert everything back to its original form. So that way, you don't want these to be counted separately. You want to make sure that they are counted as the same one. So when you are considering all the possibilities, that you understand it can be difficult for the machine to figure out how many different words that you are going to have. Okay, but let's assume we figured that already, and this is the output you are going to see. You may have different words, as each of will represent the variables, and you will have different documents, and it tell you whether each of those words show up or not. Once you have a structured table like this, you can use any cluster analysis you want to use. For example, this one, I know it's a binary table, so I can probably use the hierarchical clustering analysis. So I can either use JCAR if coefficient, or I can use a matching coefficients. But essentially, what you are going to do is that I will be able to put different comments into group. So when you are trying to visualize it, you will be able to realize that, okay, basically comment might be able to divide it into two categories. One will be considered as good comment, and one will be considered as negative comments. And especially if I count the number of times some particular word show up, maybe I will be able to predict whether that comment will be the good one or the bad one. For example, I can see how many times the customer mentioned great and how many times the customer mentioned terrible. Okay, so this way, when the machine receives a new comment from the internet, maybe he will be able to scan the comment first. If we find a certain keyword, I may realize that, okay, we received a negative comment. So maybe the manager will be able to have a pop-up screen showing up, and you have the potentially negative comment about the service you provide. So maybe you can do the follow-up phone call or things like that. So that's the way we can use the text mining and the clustering method to do the initial analysis.